In this session, I'm going to solve few of the problems which are listed in the unit 4 of your question bank, and these are the problems that I'm going to solve in the part B, the few problems I'm going to solve. So let's start with the first problem, and the first problem is you are given a boolean function, and we are supposed to express this function in the form of sum of minterms and the product of maxterm. So let's try to solve this one. First thing, you will notice that it is already in the sum of the product term. So you notice that this is the products, this is also product. X dot y is a product, x dot z, x dash or whatever it is, dot is a product. So this is one product term, this is one product term, that is summed together. So we call it as sum of products. So this is the sum of two product terms. However, we are supposed to express it in the form of min terms. So what is the meaning of saying min terms? We have to understand that thing first. So min term is a term that involves all the variables. Suppose if you have a three variables, a, b, c are the three variables, then this one term is it's a product term, a dot b dot c. Suppose your function, let me write that function. Suppose you have a function that has three variable a comma b comma c, and suppose if you, let me take this one, let me rewrite it. Okay, so let me start with the function. So we have f a comma b comma c. Three variables are there. Now if you write a dot b, this is a product term, no doubt, but this is not min term because not all the terms are there here. A is there, B is there, but C is missing. So this, even though it is a product term, we cannot call it as min term because there is it does not contain one of the variable. So we need to do something to add that one missing variable. Suppose if you have this term, let's say a dash, let me write it as a dash b c. This is a min term. Why it is a min term? It contains all the three variables either in the inverted form or in the given form, that is the true form. So b and c are in the true form and a is there in the inverted form. That's okay. So whether you have something, for example, if you have one more term here, a b dash c dash, this is min term. Why? Because it contains all the three variables. A, B, C were the three variables and it contains all the three variables. A is there in the true form, B is there in the inverted form, but B is there. Whether in the true form or inverted form, it is there. B bar or B dash, whatever you call it as, it is one and the same. So some people write it as B dash. I can't type B dash in the keyboard, so I am representing it as B dash. Okay. You can also write C bar. It is same as C dash because it's not possible to type C bar on the keyboard. Now if you look at here, the term A, B and C are there. Also let me take one more term. Okay, let me take this term, A bar, B bar, C bar. This is also min term. Why? Because it contains all the three variables. We need all the three variables. Are there all the three variables are there? They are there. They are there in the inverted form, but they are there. So if you add them, individual, each and every one of them is the product term. This is also product term. This is also product term. If you add them, then what you get is sum of products. So individual product term, sum of products is called as P. So sum of product. This is sum of product. What about this is called as minterm. What about a product of sum? Okay. So that is called as maxterm. So we have one term is called as minterm, other one is called as maxterm. What is maxterm? Maxterm is you have all the three variables. Okay. So you have a plus b plus c. This is one term. Dot a bar plus b plus c. This is the second term. Dot a plus b bar plus c bar, whatever it is. I am just writing a few of them here. So this is one sum term, this is one sum term, this is also one sum term, this is also one sum term. All of them are product, they are multiplied, or we take the product of them. So that is why it is called as a product of sum. So we call it as a POS, product of sum. Now max term is a term that contains all the variables. Suppose if you take these same thing, you have three variables a, b, c. Individual term over here contains all the terms. Individual terms over here contains all the three variables. Individual terms over here contains all the three variables. Suppose if you write like this, suppose if this is your equation a comma b comma c, then if you write a term a plus b, this is not the max term. Why? Because c is missing. Okay, so you have to somehow get that c here. Now let's look at this equation over here. So we are supposed to solve this one. Let's come back to the one that we are supposed to solve. So here you notice that even though nothing is mentioned, exclusively variables are not mentioned, but you notice that there are three variables are there. One is x, second one is y, third one is z. So x, y, z are there. So this is a function that contains three variables x comma y comma z. What is the problem with this particular function? Problem with this particular function is this particular function contains two product terms, but in first term z is missing. So in the first term z is missing. In the second term y is missing. How do we get it to the min term first? So how to get it to the min term? So let's look at that. I'm going to switch over to the PowerPoint now. So in the PowerPoint, let us look at how we can solve this equation. So given term is xy dash, I'm taken the same one, and xy dash. Now we know very well that if you take any variable, you multiply it with 1, you get the same variable. X dot 1 or 1 dot x, it is one and the same. X dot 1 or 1 dot x, this is commutative law, you know very well. So if you take x first or 1 later, or 1 first or x later, all of them will give you the answer as x itself. So x dot 1 is x itself. So here instead of x we have two terms xy. So I take this xy, you call it as k. What is x after all? It's a variable, so you can call it as x, you can call it as I, you can call it as j, k, anything of your choice. You can even call it as a dot 1 is a. Okay, so assume that these two variables together, you call them as x, or you call them as a, whatever you want you call them. Okay, so these together you call it as a. Okay, so together, this term together you call it as a. So you know very well a dot 1 is equal to a. Okay, okay, this is identity. You know very well, 1 is the identity, multiplicative identity. So what is a after all? A is nothing but x y dash. So you take, instead of a, you take x y dash, x y dash. So that is what is a. A is x y dash. X y dash dot 1 is equal to x y dash, because it is, you know very well. Okay, so anything multiplied by 1 will give you the same answer. Okay, so that is good. So what I have done in the next step is, one term is missing here. So what is missing? In this case z is missing. In this case x is there, z is there, y is missing. So wherever something is missing, I substitute 1 here. I substitute 1 here. Will it change the equation? It will not change the equation, because xy dot 1, anything into 1 is same. Xy dash dot 1 is xy dash. X dash z dot 1 is x dash z. The equation has not changed. Now we know very well that there exists an inverse for x, such a way that x plus x inverse will always give you 1. Okay. In the same way, if you have a variable k plus k inverse will always give you 1. Okay, when you add the inversion of a number, for example, if you have a 0, add what is the inversion of 0? Inversion of 0 is 1. Answer is 1 itself. If suppose you have 1 here, what is the inversion of 1? Is 0. What is 1 plus 0? Is 1. So whether you have 1 or whether you have 0, when you invert it and then add them together, you always get 1. So x plus x dash is equal to 1. Now what is missing here? So let's look at this term. What is missing here is z. So I know that z plus z inversion, add any inversion, any variable, add it to the inversion, it will always give you 1. So instead of this 1 that I added, remember this equation has not changed. Instead of adding 1, I replace that 1 with z bar. What is z bar? It is equal to 1. So it is same as 1. So instead of this 1, I have replaced it with the z bar. Why did I replace it with the z bar? Why not with the x bar? Because I need the one term that is missing here. What is one term that is missing here? Is z. Z is missing in the first term. Similarly, in the second term, y is missing. So I will replace this 1 with y plus y bar. Remember, y plus y bar is also 1. Anything with its inversion, added to its inversion, will always give you 1. So instead of this 1, I replace it with y plus y bar. Why I replaced it with y plus y bar? Because the term y is missing. In the first term, z is missing. In the second term, y is missing. So I am replacing it with the y. I am replacing it with the z. Now straight away you start multiplying it. So this is straight work. You are not doing anything. You just take this term, multiply it with this. So you get x y bar z. You take this term, multiply it with z bar. So you get x y bar z bar. So this is the next term, and there is definitely a plus. Similarly, take x bar y, multiply it with y. So x bar z y. In the same way, x bar y, multiply it with y bar. Then you get x z, x bar z y bar. You get this one. When you multiply, you get this one. So now one thing you must do is, after doing this, arrange them in such a way that you notice that they are not in the same order. So sometime x y z will come, but here x z y will come. Here again x z y. Don't do like this. Remember, according to the commutative law, x y is same as y x. So when you start with x or you start with y, you are going to get the same thing. But I want them in the same order. So here in the next step, what I've done is I will write it in the x y z order. So this is x y z, x y z, the same order. Y bar is there, no doubt. Okay, here you notice that x z y is there instead of that x y and z, so that they are all in the same order, x y z, x y z, x y z. Maybe x bar is there, y bar is there, that's not the thing. I want them in this x1 first term, y second term, z third term, so that everywhere it is same. Now let us look at the binary story that we have learnt. Let's look at this binary that we have learnt. Three variables are there. So which are these three variables that we have? So in our function we have three variables, x, y and z. Okay, every variable x can take either 0 or x can take 1. X can be either 0 or x can be either 1. So all of them can take 2. This can also take 2 possibility. Y can be either 0 or 1. Z can be either 0 or 1. So how many possibilities are there? 2 into 2. That is 8 possibilities are there. Which are 8 possibilities? X is 0, Y is 0, Z is 0. So you write it. X is 0, I'll take this as X, I take this as Y, I take this as Z. So X is 0, Y is 0, Z is 0. Next, what is the possibilities? X 0, Y 0, Z 1. What is the next possibility? X 0, Y 1, Z 0. You know very well. Then 0, 1, 1, 1, 0, 1, 1, 0, 1, 1, 0, 0, 1, 0, 1 and so on. So you know very well how to write the binary for three variables. Okay, you have done that. What is the decimal equivalent of this number? 0, 0, 0 is 0. This is 2 to the power 0, which is 2 to the power 0 is 1 here. Sorry, this is 1. 2 to the power 0 is 1. So this is 1. What is here? 2 to the power 1 is 2. So you have decimal equivalent of that. What is this one? 0, 1, 1. What is 0, 1, 1? 2 to the power 1 is 2. 2 plus 1 is 3. What is this one? 2 to the power 2, which is 4. You write decimal 4. What is this? This is 5. This is 2 to the power 2. That is 4. And 2 to the power 1. That is 1. 4 plus 1 is 5. And so on. This is 6. This is 7. You won't get 8 here. Remember, you are starting from 0 up to 7. Not 8 is not included in this one. So don't get confused. Only up to 7. 0 to 7. Not. If you start from 1, you can go up to 1 to 8 you can go. So 1 to 8 is possible. 1 to 8 is possible. But if you start with the 0, you have to stop at 7. 0 to 7. You are starting with the 0. You stop at 7. So that's that is done. Let us write the SOP terms for that. So in SOP, how do you write that? Sum of product. SOP is sum of product. Whenever there is 0, you mark it as X inversion. So 0, this is X, this is this term is Y, this term is z. Okay, so x is 0, y is 0, sorry, z is 0. So 0 0 0. So you have x inversion. Wherever 0 is there, you write inversion. Y is inversion, z is inversion. What about this term? X inversion, y inversion, z in the normal form. Next one, x inverted, z inverted, but y in the normal form. What about this one? X inverted, yz in this form. X in the normal form, yz in the inverted form. Here x and z in the normal form, y is inverted, and so on. You write all of them. What about the product of sum terms? So what is POS term? It's exactly opposite of sum of product terms. Remember, here you are multiplying it, sum of product. So this is product. Here product of sum. So this is the sum term. Exactly opposite. Wherever x bar is there, instead of x bar you write it as x. So in other words, wherever 0 is there, in the sum of product you represent it as, whenever 0 is there, you represent it with the x bar. Whenever 0 is there, you represent it with the x bar. That is for sum of product. But product of sum, whenever 0 is there, you represent it as x. What about 1? Whenever 1 is there, you represent it as x bar. Opposite of a sum of product. In the sum of product, what you are doing is, whenever 0 is there, you take it as x bar. But what is product of sum? Whenever 0 is there, you take it as x. Opposite of that. So here, this is 0, this is 0, this is 0. In sum of product, you write x bar dot y bar dot z bar. But product of sum, you write x plus, remember this is product of sum, x plus y plus z. What about the next term? This is x bar y bar z. So this is 0, that is x bar y bar z. Opposite of this, x as it is, y as it is, instead of z, you make it as z bar. Hope you get that thing. Similarly, you do it for the other one. So here you write x bar, y, z bar. Opposite of it, x, instead of x bar you write x. Instead of y, you make it as y bar. Instead of z, z bar, you make it as z. So wherever 0 is there, you write the normal form. Wherever 1 is there, you represent it in the other form. Now let us come back to the story that we have left with it. So this is sum of product term. So wherever x term is there, you write it as 1. Wherever y dash, this is sum of product. Remember, this is SOP. In SOP, wherever 0 is there, you have to make it as x bar. So y, you see y bar is there, that is why it is 0. Z is there normal, it is 1. X is there normal, it is 1. What about x is normal, it is 1. Y bar, it is 0. Z bar, it is 0. This is sum of product term, don't get confused. So this is x bar is 0, y is normal form, z is normal form. So both of them are 1. X bar and y bar, both of them are in the inverted form. So this is 0, z in the same. Now what is 1 0 1? Binary equivalent of 1 0 1. Let me show it here. You know very well, 1 0 1. Decimal equivalent of it is 5. So that is it. Okay. So let me write that thing. So 1 0 1 is 5. Okay. I have written it here. Okay. So that it comes in the order. Okay. 1 0 0, this is 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2. What is 2 to the power 2? 2 to the power 2 is 4. So you have the term 4 here. This is 0 1 1. What is 0 1 1? 2 to the power 0, this is 1. 2 to the power 1, it is 2. 2 plus 1 is 3. What about 0 0 1? 2 to the power 0, it is 1. 0 0. Okay, so all of them are the minterms. So how do you represent the sum of a product term? Sum of product, SOP, is represented by sigma. What is product of sum? It is represented by pi, you know very well. Minterms are represented by small m. What about max term? Max term is represented by capital M. So remember that thing. Okay. So write the minterms. So this is, you have already written. This is 5. This is 4. This is 3. This is okay 1. So out of this, let's go here. Out of this, you have left a few of them. Few of them are gone. Which one is gone? 5 is gone. 4 is gone, I think. 3 is gone and 1 is gone. Yes. Which one is remaining? 0, 2, 5, 6 and 7. Hope I remembered all of them. But let's if not, I will just look at it. So what is missing? 0 is missing. 1 is there. 2 is missing. 3 is there. 4 is there. 5 is there. 6 is not there. 7 is not there. Remember, out of this term, 7 terms, out of these 7 terms over here, okay, 0 is missing, I think, then 2 is missing, 6 and 7 is missing. Rest of them, 3 is there, 4 is there, 5 is there and 1 is there. Hope these are there. Okay. So what is missing? So that is what I am representing. So what is missing are these terms. So these are the 1, 3, 4, 5. These, what is this one? This is one product term. 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 All of them are summed together. So this is sum of product. So which are the terms? Sum of product terms. These are the min terms. What about the remaining? Remaining are all max term, product of sum terms. Remaining are all product of POS, product of sum terms. Okay, so simple as that. So you, whichever value are missing, they are all the max term. Now what are you going to do? You write the binary equivalent of them. What is the binary equivalent of 0? 0, 0, 0. What is the binary equivalent of 2? 0, 1, 0. What is the binary equivalent of 6? 1, 1, 0. What about 7? 1, 1, 1. So if you really didn't get it, how did I get this one? This is what I am writing. 7 is all ones. 6 is 1, 1, 0. 2 is 1, 0, 1, 0 and 0, 0, 0 are 0. This is what I am writing. So I have written that thing. Now convert them into the product of max term. How do you write in the max term? Remember, it is exactly opposite of a sum term. In the sum term, whenever there is inversion, you write 0. Whenever the normal form, you write 1. What about the other way around? Whenever there is a invert 0, you write it in the normal form. This is the product of sum term. Remember, max term is opposite of a min term. So wherever 0 is there, you represent it as 1. Wherever 0 is there, you represent it as same. You represent it as same. What about the next term? Next term, whenever 0 is there, you write as it is. Whenever y1 is there, you represent it as y bar. Z you represent as it is. What about the next term? Next term, x bar is, whenever 1 is there, you represent it with x bar. 1 is there, you represent it as y bar. 0 is there, you represent as it is. What about the last term? Last term is all of them are inverted. Remember, you have to put plus here because it is the product of sum. Every term is the product, the sum term. So you have a product of sum. This is one sum term, this is one sum term, this is one sum term and this is one sum term. All of them are multiplied together. That is why we say product of sum, product of sum term. And this is what is your equation. So this you can get it very quickly. you can manually solve them. Okay, you can get it. So I'm going to just show you once how you can do it. Now this one that I'm showing over here, this is the one that I've shown you in the previous slide. This is the whole thing, whatever I've written, I'm showing you here. Okay, so this is the one. This is already I have talked about it. Let us try to do it manually. If at all you want to do it manually, how to do that thing. So you take this term, multiply it with the x bar. You take this term, multiply it with the z. In between there is a plus here. So let us start with that. Xy plus x bar, this one term. Xy plus z, x, this is xy bar plus z. In between dot was there, in between dot is there, so as it is. Okay, done. Now take this xy term, multiply it with this. So x into x bar, in between you have plus here, x plus x bar, so this is one term. Y plus x bar, so this is y bar plus x bar, this is one. In between dot is there, so you have this dot, so that dot I have written it here. Again take x z, so x plus z, one term, y bar plus z, next term. In between a dot was there here, that same dot I have put it here. Okay, done. Now which term is missing? So which term is missing in this first term? Remember, we look at this one. This is a sum term. This is sum term. This is sum term. This is sum term. Multiplied together. So this is product of a sum term. Okay, but is it in max term? The answer is not max term. Why? In the first term, what is missing? In the first term, you notice, before I go to that first term, you know very well, x plus x bar is 1, always 1. You know, I've already talked about it, x plus x bar. Inversion, sum of inversion is always 1. 1 into anything is same. Okay, so this is x plus x bar is 1. 1 into anything will not make any difference. So I have omitted that step, assuming that you know that story now. Now I'm going to start with this term. Y is there, x is there. What is missing? Z is missing. Remember, I cannot, this is y bar. Okay, then you have I'm writing this term x bar. Now I cannot, like in the previous case, I cannot write plus z plus z bar. I can't do this one. What is z plus z bar? If you do z plus z bar, what is z plus z bar? Z plus z bar is 1. 1 plus anything will be 1. This equation is not valid. Okay, if you have 5, look at here, decimal 5. 5 plus 6 plus 1, is it same as 5 plus 6? No. 5 plus 6 is 11. 11 plus 1 is 12. Okay, so 5 plus 6 is, this answer is 11. 11 is not same as 12. But if I write 5 plus 6 plus 0, is it 11? The answer is yes, it is 11. So 5 plus 6 is same as writing 5 plus 6 plus 0. When you add 0, numbers does not change. Okay, so simple as that. So if you say x plus x bar, if you say z plus z bar is always 1. What about z into z bar? Develop it. What is develop this? Develop this is 0. Z plus z bar is always 0. So that is why, if you notice over here, I am multiplying it with z plus z bar here. Why it is z plus z bar? Because it is 0. You add 0 to the any term, the numbers will not, or the term will not change. In the same way, for the second term you have x is there, z is there. I multiply what is missing, y. So I multiply it with y plus y bar. In the third term, y is there, z is there. I multiply it with x plus x bar. Okay, done. Now, as usual, again multiply it. Okay, take these two terms, multiply it with take these two as single term, multiply it with the z. So you have x y plus z. X bar, y bar plus x, this term, plus z bar. Again take this one as one term, x z plus y, x z plus y bar. Similarly take this as one term, y bar z plus x, okay, y bar z plus x bar. Okay, all of them are product term. Okay, now try to find out whether there are some terms which are same. So let me again, it is better you write them. Look at when you write like this, it is always better you write it in the same order, x y z, in this order only you write it, so it is easier. Okay, you write this x y z, this term I am writing, this term x y z, this term I am writing it first, then I write x y z bar. So x y bar z, this term I am writing, this term. Okay, next term x bar y bar z. So x bar y bar z, I am writing this term. What about the other term? So let's look at the other term, x y bar z bar. So we have this x y bar z bar. What about these two terms? What is this term? X y z, this, look at this one, this term. If you look at this particular term, this term x y bar x z, okay, and you compare it with the, I'll first cancel this one. So x y bar z, where is this x y bar z? So it is already there. So this term is done. Now excuse me. Now the remaining term are actually there, but it is written in the other way around. Let me prove that. Which is missing is these two are missing. Okay, these two terms are already there. Okay, so remember, if you have x, again if you put x, it is not going to make any difference. So repeated terms, why? If you are asking the question why it is not there, remember x dot x is same as x. So if you multiply the same term, you won't get any different answer. Now these two terms were missing. So are this term there already? The answer is, look at this one, x y bar z, it is already there. Okay, so this term x y bar z, look at this term, these two terms, this is same term repeated. So there is no need to write it two times. If you write it once, it's okay. So this term you can ignore because it is already there. What about the remaining term, this term x y bar z? If you look at this x y bar z, look at this one, x y bar z, x y bar z, this is already there. So instead of writing them 2 to 3 times, you will notice that they are same. These three terms are same. Write it only once, don't repeat it. So it's like if you write the min terms here, if you write this min or max term or whatever it is, when you write the min term or max term, if you write 0, this became a max term, whatever 0 0 dot 0 dot 0, Will it make a difference? It's 0. If you write it once, that's enough. Put the next term. Okay, so if you write it once, that's enough. Again don't go and put the same term there. It's not going to make any difference. But what is important here? The important thing is you will, if you compare it with this one, if you compare it, this term, this term, this term and this term, it is the same. How did I get this one? I got this one from the previous explanation. From here it is the same term that you are going to get, but here it is much easier. This option is much easier. Let's go and let's solve the second problem there. So if you look at here, the second problem that is given over here is this one again, same y, z and so on and so forth. The problem is given. I quickly shift to the PowerPoint, and what are the things which are there? How many variables are there? First thing, you have to understand how many variables are there. So in this case, you have x, y, z, w. 4 variables are there. So how many possibilities are there? Possibility is 2 to the power 4. So what is 2 to the power 4? 16 possibilities are there. Which are those 16? From 0, 1, 2, 3 and so on up to 15, not the 16th one. Remember, when it was 8, it was 0 to 7. When it is 16, it is 0 to 15. 16 is not included. Okay, so let's go ahead and let's solve this one. First of all, I'm going to get it for the minterms. What is missing in the first term? Y is there, W is there, X is there, Y is there. What is missing? Z is missing. So you know very well, Z plus Z bar is 1. 1 into anything is, it's not going to make any difference. Okay, same thing. What is missing in the second term? W is missing. W plus W bar, anything with this inversion, sum of inversion is 1. 1 into anything is same. So equation is not changed. Only thing is you have to take this term, multiply it to the z. So x y w x y bar z, again w x y bar z bar. So next time this, okay, in between plus is there, you write that. Again you take this term, x bar y bar z into w, x bar y bar z into w, first term. Second term, x bar y bar z w bar, in between plus is there. So that's done. Okay, now only thing is, whenever you write it, write them in the same order. So you notice that sometimes w is first, sometimes x is first and so on, but just rearrange them so that they are all in the same order. So I write it in x y z w. So same thing, only thing is x is written first, y is written next, z then w. Just rearranging the terms. So x, y, z and w as it is. If x bar is there, you write x bar, z bar is there, you write z bar. Again x bar, y bar, z, w. X bar, y bar, z, w. Okay, so you got all of the terms now. Now wherever 1 is there, this is SOP. Wherever x is in the normal form, right, y is in the inverted form, put 0. Z is in the normal form, write 1. W in the normal form, write 1. Plus, as this plus is not required because I have just put the plus there. It doesn't make any sense there, but it is there. Okay, just to show you that it is the same thing. Okay, you write x 1, y bar 0, z bar 0, w is 1. Wherever the normal form, you write 1. Inverted form, you write 0. This is sum of the product term, remember. Then x bar is 0, y bar is 0, z1, w1. X bar is 0, y bar is 0, z is 1, w bar is 0. What is a 1, 0, 1, 1? So you write, I hope you know the, I don't know whether I have put that thing. Okay, I think you are familiar with this one. What is that thing? 2 to the power 0, 2 to the power, so this is 2 to the power 0, this is 1, 2, 2 to the power 3, 2 to the power 4. So what is this one? So this is I will write I think that is 11. I don't have to prove you that that is 11. Okay, but still I'm going to write that thing for the first time. 2 to the power 0. Writing using mouse is a bit problematic. 2 to the power 1. Okay, this is 0, and 2 to the power 2, and finally 2 to the power 3. Okay, what is 2 to the power 3 is 8. What is 2 to the power 2 is 4. 2 to the power 1 is 2, and 2 to the power 0 is 1. What is given over here is 1 0 1 1. So 8 plus 2, that is 10. 10 plus 1 is 11. So you write 11. 0 0 1 0 0 1. 8 plus 1, it is 9. Okay, this term is 9. 0 1 1. So 0 0 1 1. 2 plus 1 is 3. You write that 3. This is binary equivalent. This next term is 2. These are all min terms. What is missing? What is missing? Up to 15 numbers were there. 0 is not there in this one. 1 is not there. 2 is there. 3 is there. 4 is not there. 5 is not there. I think 6 I missed, sorry, 6 is also not there. Okay, 7 is not there. 8 is not there. 9 is there. 10 is not there. 11 is there. 12 is not there. 13 is not there. 14 is not there. 15 is not there. So many, I think I have missed 6 here. The equation that I am writing is actually wrong. The 6 I missed it. Okay, so 6 is also not there. Okay, so these terms. Now write the binary equivalent. 4 decimal places, 4 bits. So 0 0 0 is 1. 0 0 0. What is 1? 0 0 0 1. What is 4? 0 1 0 0. What is 5? 0 1 0 1. What is 6? You write, I have not written. What is 7? 8, and so on so forth. You write all the binary equivalent of it. In the product of sum term, look at here, in the product of sum term, it is the exactly opposite of sum of the products. In the sum of the products, if 1 is there, you write x. If 0 is there, you write y bar. In the product of sum, it is the opposite of this. If 0 is there, then it is a normal form. Remember, all of them are in the normal form, separated by plus, not by dot. This is product of sum, and then you write dot. Again, what is there? This is x, y, z, but w bar. Okay, what about the next term? Next term is let's go here. Next term, x, y bar, then two terms are same. What about the next term? You keep on doing it, and hope I won't explain it till the end. So first one is normal. These three are inverted. These three are inverted. Keep on doing it. You write all the terms one after the other, and you get the solution for that, and that is the product of sum terms. Now let's go to the next question, which is written there, and that is using the theorems simplify this term. Okay, let me try to simplify this term. Okay, so how do you simplify the term given here? Write as it is. I have written this term. Whatever the term that is written over here, I have written it as it is. I have written, so no changes. When I copy pasted it, there was no change. Okay, now start taking these two terms, multiply it. Taking these two terms, multiply it, separated by plus. So a dash b d, a dash b d, a dash b c dash d. Okay, this is the next. B into a and b into this term, ba plus b a dash cd. Okay. Now slight rearrangement I am doing it. I am doing it because I want to show you that the equivalent the nearby numbers are there. So what I have done is I have written this first, this next. Okay, y x plus y is the same as y plus z. What is this law? This law is the commutative law. X plus y is same as y plus x. Whether you start with the x, whether you start with y, you are going to end up with the same answer. Okay. So now I brought this term here. Okay, this term here. Why? There is a reason for that. What is that thing? So what you notice here is you have a bar, b and d. A bar, B and D the same, but the C and C bar is different. So take this term A, B and D, A bar, B and D, take them outside, keep C and C bar. So you take these terms, this term common. What is x plus x bar? I have already told you. X plus, according to the identity, when you multiply it with, when you add with the inversion, it is always 1. Okay. C plus C bar is always 1. 1 into anything will not make the changes in the equation. So that is done. Now again slight modification in the next. Remember, 1 into anything will not make any difference, so there is no need to write that one. So again slight rearrangement. Okay, I've just brought it here. Why? Because there is a reason. What you notice over here, you notice that a bar b is there, a bar b is there, but d and d bar is different. So take a and a bar b common, d bar d. So if you say that C bar plus C is 1, then naturally, as far as the inversion is concerned, D plus D bar is also 1, and multiplying it with 1 will not make any difference. Now ignore this one, look at this thing now. What is common here? B is common. You take B common. What is missing? What is remaining? A bar and A. So write A plus A bar. You know very well, if x plus x bar is 1, A plus A bar is also 1. 1 into anything is 1. So what is remaining with you is B. That is the simplified solution for the given problem. Let us prove the next one. That is the, I think this will be the last one that I am going to solve. Which one? This one. Okay, this. Yeah, prove that x plus x bar y is x plus y. Okay, this is what you are asked to prove. So prove that x plus x bar y is equal to x plus y. Take the left hand side term, LHS term. What is x plus x bar y? Multiply it. So you have no choice. Multiply x with the x bar, multiply x with the x bar. Okay, so x plus x bar and x plus y. What is x plus x bar? You already know. X plus x bar, inversion is always 1. 1 into x is same. 1 into anything for that matter is same. So 1 into, you take 1. What is remaining? xy. 1 into anything is same. So what you get to this one? What is this after all? This is the right hand side, and you have just proved it. Let's look at the next. There are second question was there here. If you look at here, there is this second question. Let me try to prove that second question. What they have written is they have given you this few options over here. So let's take the left hand side and let's try to prove that left hand side is equal to right hand side. So take the left hand side, write it as it is. Okay. Then see what is common. You notice that among this x bar z and x bar z is common, but y and y bar is shifting. So you notice y bar here, y here. To take x bar y common, keep y plus y bar. Okay, if you multiply it, you are going to get the same thing. If you x bar y into y, you get the same thing. Okay, just take in the common term and you keep the remaining term as it is. You don't touch it. Y is y plus y bar. You know very well, y plus y bar, anything if the inversion is 1, and the inversion with the 1 into anything is same. So you get this one. You anything is that x plus z bar, x y bar. What is this at the end? You notice that that is same as the right hand side, and you have proved the solution for that. With that, I will conclude this video. Thank you for viewing this.